Hello, this is Jennifer Martinez, and in this video we're going to look at functions, modeling, and proportionality. And this is section 1.5 on page 25 in your class notes notebook. So let's first look at example 1. It says, suppose sales tax is 9%, and let C be the sticker price of something and T be the total price, including sales tax. Part A says fill in the table. Since C is the sticker price, we have here C is the sticker price is $10 and T is the total price. So how we're going to go ahead and find that total price is we're going to take the sticker price times the sales tax, which is 9%. So 9%, which is 0.09 times $10 added to the $10. So 9% of $10 is 90 cents. So that's 0.90 plus $10. So that's $10.90. And that's in dollars. When it's 50, so we're going to take sales tax is 9%. So 9% of 50, that would be, if you use your calculator, $4.05. And then you have to add on that 50. So that would be $54.50. So that is part A. I'll wait to do the other two until I do part B. Part B says to write an equation for T. So again, T is the total price and C is the sticker price. And we know that that's a total price including sales tax, including tax. Okay, so what do we do here? T was equal to, we took 0.09 times the sticker price each time, so that was C, and then we added it to that sticker price. So if you combine like terms here, this is an imaginary 1, so you get 1.09C is the formula for the part B, the equation for T in terms of C. Either one of these is fine, but we're going to look at the second one. So you can do these in another way. You could take $100. So to find this one, we could take now 1.09 times $100. And we get $109, which by the way is the same thing. If you took 0.09 times 100, it'd be $9 plus that 100. 9 plus 100 is still 109. So you can now do this by using this equation instead of the top one because they're like terms. So the same thing with this one. T would equal 1.09 times 200, which would equal $218. So $18 would be the sales tax. So part C. What can you say about T over C? Well, let's just check it out each time. So in the first case, we would have 10.90 in the first set over 10. That would be 1.09. In the second case, 10 over C, we would have 54.50 over 50. Do that on your calculator. We're going to get 1.09. One more time, T over C, we get 109 over 100, which is 1.09. You can see that here, because if you divide both sides by C, you would get T over C. Let's just actually do that. T is equal to 1.09C. Divide both sides by C, and you can see that you would get T over C is equal to 1.09. That's the answer to part C. This would be the answer to part B. Finally, part D, we'll do it over here. What happens to T when C is doubled? It doubles. You can clearly see that right here. Let's do that in green. When C doubles, so does t. So this is 109. If you take 109 times 2, you do get 218. So that's the answer to D. Example 2. A tutor gets paid $60 for 4 hours of work. Write a function of E, their earnings, and earnings are in dollars, after T hours of week. So T is the hours of work, sorry. Hours of work. Part A asks to write a function. So if we get $60 every 4 hours of work, that means if we work 0 hours, we would get $0. We'd earn $0. What happens after 1 hour? I do realize after 4 hours, they tell me it's 60. But what about after 1? If I take here the same idea, 60 divided by 4, they're going to call this proportional. The proportion is 60 over 4. That's $15. So this is $60 over 4 hours. So that would mean that we would make $15 every hour per 1 hour, or $15 per hour. That would be our rate of change. Now, so after 1 hour, it'd be 15. So we're going to see, this is again like example 1 here, right? The tax over the cost, or the price, was 1.09. Now the earnings over the time is going to be 15. Or E is going to be 15t. And you can see it would work when we plug in 0 here. We would get 0, 1, 15. 4 would be 60. Let's try another one. Let's try 8. 8 should be another 60, so it'd be 120. And if I plug an 8 in here, E equals 15 times 8, you do indeed get 120. I'm sorry, that was still A. B asks a different question. Find the rate of change of f of t. So I'm going to call this f of t. E is equal to f of t. So I'm going to find the rate of change from 5 to 7. Should be 2 hours. It should be $60. Let's see if it is. The rate of change we know is delta y over delta x, where the x is the t and the y is the e. So we have delta e over delta t, or f of the b, so the 7, minus the f of the a, which is 5 over b minus a. So 7. What would 7 be? F of 7 would be 15 times 7. Minus f of 5 would be 15 times 5, which, by the way, would be 105. 15 times 7, 15 times 5 is 75. And then we'd have 7 minus 5, which is 2. So it looks like the answer is 30 over 2, which is 15. Still 15. So you maybe thought it was 60, right? But we're looking at the rate of change. This is now 15 to 1. So this is dollars per hour. It is a rate of change. So every hour, every 2 hours, by the way, we are making 30, but you divide that with 2, it goes back to 15. Example 3. Write a function for C equals g of m, which gives the number of centimeters in m meters. So C equals the centimeters and m equal meters. If you know anything about centimeters and meters, there's 100 centimeters in 1 meter. So if I was to do a chart, the m is our input, the c is our output. So if I said I had 1 meter, that would be 100 centimeters. 2 meters would be 200 centimeters. 3 meters would be 300 centimeters, and so forth. So again, how I'm getting this is 2 times 100, 3 times 100. So write a function. So C equals g of m is equal to 100 times the number of meters. That's the way we did it in part A, or example 1. You could have also said centimeters to meters is 100. There's 100 centimeters to 1 meter. So you can see that you can also get it using proportionality. So this would be the same as C over M equals 100 over 1, multiply both sides by M, and you would get C equals 100M, which is the same answer that we got over here. And by the way, here are the answers for example 2. So here's the definition. We say that Q is directly proportional to T if Q equals K times T, and K is a constant. So notice in this case, the constant would be 100. Or you could write it like this: Q over T is equal to some K. Again, K is called the constant of proportionality. So that's why this first line is a K there. If T doubles, then Q doubles. We saw that. You can see it here. If we did 4, it'd be 400. Right, 1 to 2 is doubling, so it doubles double. 2 to 4 is doubling, 200 to 400. If T increases by 1, then Q increases by K. This is like a rate of change. And we saw that as it increases by 1, this increases by 100 here on the example above. The rate of change, oh, there it is, delta Q over delta T is also K when you have proportionality. So all functions that we've been looking at are not proportional. And here's some examples. So part A is, because you can think of this as 1 over 53 times x, so it is some sort of K times T. By the way, y equals, I know they use Q equals KT is proportional, but they could have used y equals KX if you'd rather use KX. So that's what we're looking for, direct proportionality, directly proportional. So in this case, y is the Q and x is the T. So here is a yes. If it is yes, give that constant. So K is equal to 1 over 53. Even in part B, the answer is yes, because we could change this to, add them together, 7a. So it's a K times the variable. So yes, and the K is 7. Even with radicals, it could be a fraction, it could be a number. Here this would be yes, K would equal square root of 5. That is a number, you can get a decimal for that. This one is no. This is not just some K times T. So all of these, if I let this be equal to y, for instance, I would get y over a equals 7. This one, the other is the same idea. This one, the answer is no, because you can never get that proportionality because you have that plus 2. If we try D, for instance, 0 would be 2. 1, if you plug a 1 there, you would get 7. And 2 would be 12. So here, 12 over 2 is 6. And over here, 7 over 1 is 7. That doesn't make sense. They are different. The answer is no. Versus if you look at part B, you would have a versus the y, which is f of a. You would have 1 would be 7, 2 would be 14. They would divide, 3 would be 21. And you can see here 21 over 3 equals 14 over 2, which equals 7 over 1. They all are the same. So that's why part A is a yes, or part B is a yes, where part D is a no, just comparing those. Here's the answer for these two.